This is section 6.1, part B, mean of discrete random variable. When we analyzed distributions of quantitative data in chapter 1, we made it a point to discuss their shape, center, and spread, and to identify any outliers. We will follow the same strategy with probability distributions of random variables. The mean of a set of observations is their ordinary average, and we are going to talk about the x-bar. So the mean, or mu sub x, of a discrete random variable x is also an average of the possible values of the random variable x itself, but with an important change to take into account the fact that not all outcomes may be equally likely. So suppose we have a random variable x, and it is a discrete random variable. To find the mean, or the expected value, you're going to multiply each of the possibilities by their probability and then add the products together. So in an earlier example, we defined the random variable x to be the Apgar score of a randomly selected baby. The table below gives the probability distribution of x once again. Compute the mean of the random variable x and interpret its value in context. So to find the random variable, you are going to take the x value and multiply it by its probability. And you're going to add it to the next x value, or the random variable, and you are going to multiply it by its probability. You will continue doing this for each of the values until you get your answer. And in this case, our mean, or our expected value, will be 8.128. So this means that the Apgar score of a randomly selected newborn is expected to be an 8.128. This means in the long run, the average Apgar score of many, many randomly chosen babies would be 8.128. Suppose that x is a discrete random variable whose probability distribution is given in a table. To find the variance, and remember, the variance is just your standard deviation squared, so that's why it is sigma sub x squared is your variance. To find this, you're going to do your x value minus the mean squared and then multiply it by the probability. Then you'll add on the next x minus the mean squared times its probability. When you add all those together, that will give you the variance. Remember, to find the standard deviation, if you have the variance, all you have to do is take the square root. So compute and interpret the standard deviation. To do this, the first thing you would have to do is find the variance. And again, to find the variance, you have to know the mean. So you would do your first x minus the mean squared and then multiply it by its probability. Then you're going to add the next x minus the mean squared times its probability. The next x minus the mean squared times its probability. And you would continue that on until you had all of them done, and you had your variance is 2.066. But to find the standard deviation, remember, you take the square root of the variance, and you're going to end up with 1.437. So on average, a randomly selected baby's Apgar score will differ from the mean of 8.128 by about 1.4 units. Now, the good news is your calculator can do all that work for you, so you don't have to do it all by hand. So let's look at the exact same data again, but this time we're going to use our calculator. So you would start by entering the values for your random variable, or your x values, into your list 1, and you would list the corresponding probabilities into your list 2. To graph a histogram of the probability distribution, you're going to make sure, first of all, that your y 1, or all your equations in your y are cleared out, you're going to go to your stat plot. You're going to change it to, so plot 1 is turned on, and you're going to change it to a histogram. Now, the difference here is your X list is going to be L1, but you are going to change your frequency in this case. Frequency is normally just 1, but you are going to change it to list 2. And to do that, you can hit second and then the number 2, and that's your list 2. You can adjust your window by, remember, hitting zoom and then 9, and that will give you zoom stat. So to calculate the mean and standard deviation of the random variable, you are going to use your one variable statistics again. Again, you're going to go to your one variable statistics. In list 1, your probabilities will be in list 2 still. When you hit the one variable statistics, to do that, remember you hit stat, you go over to calculate, you're going to select that one var stats. Your list is going to be L1, and again, our frequency is going to have to change. Your frequency is normally just 1. You are going to change your frequency to list 2. Again, to do that, you would hit second 2, and that will bring up L2, and then it will calculate the values for you. And again, you can see that our mean is 8.128, and our standard deviation is 1.44. Let's check our understanding. A large auto dealership keeps track of sales made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. So in the first hour on Fridays, the probability of selling a car is 30%. Not selling any cars is 30%. Selling one car is 40%, 2 cars is 20%, and selling 3 cars within the first hour on a Friday is only 10%. We need to compute and interpret the mean. Remember, to find this, you're just going to do your X value times the probability, and then add the next one, the X times probability, X times the probability, and X times the probability. And when you find that value, you're going to get that your mean is 1.1 cars. So this means on average, we would expect them to sell 1.1 cars in the first hour on a Friday. Compute and interpret the standard deviation. So we first need to know that the mean was 1.1. Remember, to find the variance, or the mu sub x squared, you are going to take the X value minus the mean, square it, and multiply it by the probability. X value minus the mean squared times the probability. X value minus the mean squared times the probability, and X value minus the mean squared times the probability. When you get that, that will be your variance. To find your standard deviation from there, you then have to take the square root. And if you take the square root of your variance, you should get that your standard deviation is 0.943. So this means, on average, the number of cars sold on a randomly selected Friday will differ from the mean of 1.1 by 0.943 cars sold.